Thank you, everyone. Welcome to the Ottawa AI and Machine Learning Group meetup. Today, I'd like to present to you the talk by Petar Djukic, The Human is the Loop. Petar is here and the floor is yours.
Oh, thank you. Okay, so let me just maybe say a few words about myself. So I been in software development now for uh, over 25 years. And I started to look into how do you create software with agents, and how do you do that reliably. And so I've been kind of thinking about this and doing it, and also started to have some thoughts about the kind of skills a person would have to be able to be successful at that. And this talk is reflecting that. I think based on the audience feedback from beginning of the talk, I think I'm going to maybe not quite say what's on the charts because I want to maybe relate it to some of the people who maybe don't have many years of experience coding, and just to make sure that they can relate this to what they do that's not just coding. So I'll do that. Okay, so you can find, so I put my Substack here, and there I put how-tos on how to use agents. So hopefully that's helpful to people. All right, so this talk specifically is about loop engineering. And loop engineering is this term that came up like in June timeframe. All these sort of famous people in AI were saying, "Oh, well, I don't really code anymore. I loop engineer now." And I was like, "What does that mean? What do you mean by that?" And really, what they mean by that is that instead of prompting the agent to do something, you actually get the agent to write the prompt to do something. That's all they mean, right? And then when you are able to do that, you're kind of automating a large part of what you would normally do. So for many of you, when you use something like Claude or OpenAI, it works in both of them, ChatGPT or Claude. You might be in a chat window, and I'll show you a chat window like in a couple of minutes, but you're in a chat window and you're having an interaction with the model. You're asking questions, it's giving you responses, and then you're shaping what the agent is telling you towards where you want to go. Okay, so you can do that when you develop software too, where you're kind of telling the agent what to build, and you're doing it kind of like one step at a time. And this is probably how most people would start working with agents in software development, because what they're doing is they're kind of saying, well, I would have written this function, so I'm going to get the agent to write the function, and then you kind of go like that. But actually, I think if you want to really scale that up and actually really be much more productive with the agent, then you have to really think about, what's my role and what's the agent's role in this entire process. Okay, so that, and this kind of talk kind of goes into that and tries to explain it. Um, so so when I think about this and what a person should be doing and what a person needs to know, and I think this is what I tried to focus on in this talk, I wanted to kind of frame it in terms of skills you would need to have to be able to do loop engineering. There's the mechanics, and I'll show you that. But I think in the end, actually, more than mechanics, there's sort of certain kind of craft skills you need to have, right? That kind of enable you to create loops and to get these agents to work for a very long period of time on something you want. Um, and the first one here I list is, getting the agent to write your prompt. Maybe some of you already tried this. Like I know early on last year, I would be asking ChatGPT to write a prompt for Claude and asking Claude to write a prompt for ChatGPT many times to summarize the conversation already ongoing, so that I can transfer information between the two tools. Okay, that's kind of one thing. The second thing is long-term memory management. And this has to do with then I'm working on this task, but it's not a single task I can do in one chat. I need to be able to break the task down into multiple tasks, and then get the model to perform those tasks without having to have a really super long window. Now, here I describe tasks that are code related, but this also works on any kind of writing. It also works in data analysis. Somebody mentioned they want to be a data scientist. I used to be a data scientist at some point, or ran a data science team. Yeah, you can actually take any task that you would normally do, and as long as you know how to break it down into smaller pieces, then you can use this long-term memory management skill to be able to record what the pieces are, and you get the agent to record the pieces into GitHub, and then you can use the task from there to break the task down. The third part here is going to be, I think, challenging for some people in this talk to fully understand, but it's about being able to enabling agents to work in parallel. Okay, so if I have the same directory and the two agents are touching the directory, they're going to rewrite each other's files. So what we want to be able to do is to create a situation where the agents are not colliding with each other. A very simple way of doing that is to have two repository clones in two different directories, and that way, there's no conflicts. Here I show a bit of a more advanced one, which is using what's called a Git worktree. And I'll show you how that works. And then finally, I have this other thing, which is, let's say you have a task, and this kind of goes back to something like the Hermes agent, or what people call OpenClaw. That agent is able to schedule itself to do jobs. And all that really means is that it saves a prompt, and then on a schedule, it passes the prompt to the agent, and then the agent does something based on the prompt. So what we do here is we save the prompt in GitHub. And then later we can go and retrieve the prompt and actually get the agent to do what we wanted him to do on a schedule. Okay. Now I don't schedule it per se because I don't find that useful, but like I know that I have the prompt and I can just run it when I need to. Okay. Kind of like you could say, check all of my emails and then filter out for this. That could be the prompt, and you can just trigger when you want. You can trigger it every 5 minutes if you want that way too. Okay, so now what I have here though is I have the links. So these are all kind of what I call them how-tos that I have on my personal blog. And if you want, you can go and read them as well. But I'll show you on the presentation how they all work. All right, so now let me kind of go here and maybe discuss this thing. I called it this vibe coding versus loop engineering. Vibe coding to me, there's many different ways of saying it, but to me, vibe coding is when I'm interacting with the agent and we're just kind of going back and forth, we're building something together, whatever that is. Okay, so it could be a PowerPoint, it doesn't have to be code. When you step back and say like, well, what am I actually doing as a human? Like, what am I doing in this interaction? Okay. And there's sort of several things that you didn't externalize necessarily when you work with that agent. So one is you have this memory in your head about everything you've done so far. Okay, that the agent also has, but the agent doesn't know what to do with it. So and oftentimes the agent will kind of forget, and then you have to remind it. We already did that, so that it doesn't repeat the work. The other one is coordination between tasks, right? Like you kind of like, inherently when you work with it, what are the tasks? You break the problem down for yourself and you kind of work on those tasks step by step. PowerPoint, each slide, right? Or if you have code, maybe each file or each function, or each class or each interface, you will have some plan in your head how you want to build that thing you want to build, okay? But the agent doesn't know, so you need to be able to externalize the knowledge and give it to the agent in some way. And then you have the shared context, which is, like two agents working on the same thing, and they need to know that the other agent already built something. Like if you work with agents like this, what you'll find is that oftentimes they'll build the same thing twice, or there's a library you want them to use, and they'll just rebuild it again. They're kind of like their training kind of forces them to do that. Inherently, they try and fix the problem without actually looking for a solution that already exists. So it's a kind of a fault in how they train them. And then finally, there's like a stop condition, which is how do you know you're done, right? I mean, like the model doesn't know. I mean, like with the coding, maybe it knows when all the tests pass, but like if you're building a PowerPoint or something, there's a certain amount of taste that you bring in as a human, and you kind of tell the model, we're done with this, we can move on. Okay, so those are kind of all the skills that you as a human actually doing as you're working with the agent. Okay, even though maybe you didn't think about them as separate aspects and like kind of break them down into the list of four. Okay, so now in the loop engineering, what we have to be able to do is to transfer those skills to the model. Okay, so that's kind of how the skills listed. And now what we're trying to figure out is, okay, so how do we do memory management? Well, okay, we submit issues to GitHub. Okay, I'll show you how that works. How do we do coordination between tasks? Well, actually, GitHub keeps a dependency between issues, and it knows which one should go first, which one should go second. Okay. How do we share the context? Well, we're going to use work trees because we're going to isolate agents from each other, and they can all work at the same time on same code bases. Okay. And then finally, we have the stop condition, which is, well, it's done when it solved all the issues. So there's a backlog we create for the agent, and the agent can stop when the backlog is finished. Okay, so I can pause here and say, are there any questions at this point? Because now I'm getting more into like how loop engineering actually works.
Uh, yeah, if anyone has questions, let's just unmute yourself and ask. But generally, I think Petar, you paused on the most interesting kind of a real cliffhanger here. So I think everybody is anticipating the
All right,
actual.
let's go.
So
Let's go forward
I'll
then.
let you continue. Yeah, thank
Okay,
you.
I'll continue. Okay, so All right, so let's talk about the loop. Okay, so the loop kind of has sort of typical, maybe not typical for everybody, but like you can also kind of think about how does the process something works. There's always the planning of the work, and then there's doing the work. Those are two parts of a work loop anywhere, right? So in this case, what I did is I kind of broke this down into four different commands. There are commands you can call up in Cloud Code if you have the right set of .cloud directory, and I'll actually show you how that works in a second. And then those commands are certain things. So for example, make work does the plan. The push command will push the plan into GitHub so that they're saved for later. You can retrieve them later. The pop gets something from GitHub and starts working on it. And then the do work one is the one that actually does the work. Okay, so I'll show you how those relate together in a second. So, okay, so let me just, now the way I kind of structured this was like skill by skill, and the skills relate to these commands. So you'll see four different skills that I want to show you. And then for each skill, I'll show you how you use the command related to that skill and what the command does in Cloud Code. So this one here is so getting the model to write its own prompts. Okay, so basically, I have this repository here, and just to show you, like I actually this in my job, I wrote this piece of software that's open source, and there I have 15,000 issues that were solved and PR'd. This is in a period of 4 to 6 weeks. And there's 80,000 Go code in that project. Okay, I didn't touch any code. It was all written by Cloud Code, right? But like what I want to be able to do there is to say, I'm going to create a backlog of issues Cloud can work on its own and maybe overnight. So like it takes it 8 hours to do that. So I'll create enough issues for Cloud Code to be able to work on it its own. Not to say it's perfect. You still have to go check what it did and like, redo some things. But, it's better than me writing code for, 80,000 lines of code might take me 6 months. So like if you can do it in 6 weeks, I think that's a good speed up. Okay, so now what I did for this stock, I have this, and maybe we should talk later how people can find this out, but like that's like a repository that's open source in GitHub. And I just want to kind of take you through a short tour of GitHub so you see what's going on here. So here what I have is I have the files that are in this repository. Now for me, when I do work or when I do something other than writing code, I'll have the same structure. I'll have a repository, say for a paper I'm writing, or I'll have a repository for a presentation I'm building, or I have a repository for my Substack blog. Okay, so like they're all separate directories, but they all kind of look like this because I always use the same set of commands and use the same procedure everywhere. So in this one here, what we have is we have this docs directory, which kind of describes what this software project is. And I made something that we can run in a, kind of like short time. So it's just a hello world Go program. That's all it is. That's kind of that one thing. The other thing to note here is this tab called issues. So when we run Cloud Code, it's going to record issues and they show up in here. And that you'll see them later. When I run something in Cloud Code, you see the issue being created. Okay. And the other thing I should point out here for this presentation, it's actually stored right here. So if you later want to run it, there's a README here and shows you how to run it. You can actually run the demo yourself. Okay, so all right, so that's kind of that. And so I was kind of alluding to this, but basically when you're in Claude, you will say, I want you to write a prompt and I want you to save it in GitHub. So the first example I have is exactly that. So this skill 1, okay, so now this is kind of in my way. Okay, so this tab here is Cloud Code. Okay, so it's just running in my browser. Let me just see, who are you? Let's see if it knows who it is. Just to make sure it's Cloud Code. That nothing happened since last night. I'm Claude. Okay, great. So we have Cloud Code. It's running in here. And then to get it to create, so as I was saying, this repository describes the requirements of a Go application that just prints hello world. Okay, so it's very simple. So what we want to be able to do is to tell it to create some backlog to start writing that application. So first thing I do is I'll copy this prompt and maybe describe it as it's running because it takes about a minute to run. Let's hope it works. Okay, great. So I pasted it. Okay, so see in the prompt what it says, I have this command called make work, but then I also tell it what to do. So make work is like a skill that Claude reads, and then he knows what to do. And in that skill, what it's able to do is to kind of follow a certain set of instructions. Okay. And based on the instructions, it's going to do what I asked it to do. Okay. Um, so let me see here. I don't have it open. But basically, that skill says go and read these files that are in the directory. And then when you read them, go and download all the issues that are open. And then based on that, come up with some work that we can put into GitHub. That's kind of what the skill says to Claude Code. And then Claude Code does that. Okay. So he says here, okay, well, I read this, that you asked me to do. I did all of these checks you asked me to do. And then I'm proposing some work. I have one epic and two sub issues. I'll show you what it looks like in a minute when he creates it. And it says, okay, based on the description of what you gave me in that directory, I need to create two separate things. One is this one file that does hello world. And then the second thing is this other file that says it's a version, what version of the software we're in. Okay, so now I'm going to say here, so this is kind of what it says it plans to do. That's what Claude said it plans to do. And I'll just say approved, like so. So now what's going on is Claude Code is taking these instructions and it's creating issues in GitHub to describe the work that we just planned. Okay, so this takes about some amount of time. Maybe we can see if there's any questions while that's happening. Any questions so far?
Uh, I actually have few questions,
Oh,
but
yeah, good.
yeah, if other people want to interrupt me, go ahead or kind of write on chat because yeah, I can take a lot of kind of time here. So I don't know if you want, do you want to describe or you're just proceeding? Okay. So the question I have, so you said that it's creating issues in GitHub, but
Hmm?
I didn't quite like based on what? So you had already some issues, right? And then it's going to write more issues on top of
That's
these
right. Yeah.
issues.
Yeah. Yeah.
And so why is the original set of issues not enough that you put in there? Like
That
why does
that's
it?
actually, yeah, it could have been enough. I wanted to do a demo where it creates a new issue. But
Okay, I
yeah, yeah.
got it.
Yeah, yeah. So I made it so that it works like that. So yeah, if I look at GitHub right now, and these issues, I'll talk about them at the very end. They're what I call recurring issues. So there
Hmm.
are issues that are standing, and you can just call them up and say, like, I want you to do this. So it's like, run a regression suite. That could be an issue that you get it to do. And then it runs a regression suite. And a part of the issue would be if you find a bug, go fix it. Right. So that issue creates new issues because it'll find
Okay.
bugs and then log issues to fix the bugs. Right. So yeah, that's kind of like those are kind of those issues there. Now for this presentation just now, it created these three issues just now. I just finished. So the first issue is an epic, meaning that I created like a group of issues. And then I created two issues under that epic, one to create this main.go and one that creates version.go. Okay, so if I read this one, sorry, did you have like more questions based on that? Because I'm going to show you what's in the issue.
There is one question in
Yeah.
chat from Trevor, but I'm not sure what PRD stands for in this. So Trevor, if you could expand, but yeah, I don't know, Petar, if you see in chat. So I'll read the question. It says, so you're taking a PRD, asking Claude to break up the PRD into issues in GitHub. Then you'll use work trees for multiple Claude agents to work on each issue without stepping on each other.
That's correct. Yeah. So PRD stands for product requirement document.
Okay,
Now,
sounds great.
in the case of this, I actually call them software requirement documents because they're not like they're actually like the way I create them is they have components and interfaces, not just like this is what this product does. Yeah. But essentially that's what it is. You have to give it a description of the software and then you get it to break down how to build the software. Yeah.
Sounds great. Ahmed, go ahead.
Yes. So is the Claude have a free will to write the issues, or do you give them a specific template to respect it?
Yeah, so in the make work skill, it says what to put in the issue. Okay, so for example, like it create like now I'm realizing I should have had that different repository open too. So basically, when it creates an issue, it will follow the same format for every issue because we tell it that in the skill to answer your question. So here it created an issue. This is like, oh, so right here. Sorry, that was this tab here. So he created two issues. He's created 97, 98, 99, and now we're looking at 98. That's one of the issues. 97 was the overall epic holding issues together. Okay, so in this one, he says, this is what the issue looks like. There's a thing I want you to read before you start. So you figured out you need to read all of these files. And some of these, like this SRD, that's what the gentleman was asking about was a PRD. Like you need to read this description of the functional description of what it's supposed to do. And then he says, these are the files I want you to create. I want you to create main.go. I want you to create a package, and I want you to modify this file here, which is just the Go thing, okay? And then it says, these are the requirements you have to meet when you're done with this. The requirements of want this piece of work to accomplish. And then you say, and this is how you can test it. Okay, so it says, these are the acceptance criteria. I want to get this exactly. That's what the test acceptance criteria are for this. And then it kind of says everything else, okay? Does that make sense? So this was this issue here is actually was created by Claude Code. Okay, so he wrote everything down based on the design that he had and based on what we asked it to do. Okay. Any questions on that? Because the next thing is because actually now this issue becomes the next prompt. You see, so we wrote the prompt, we stored it in GitHub, and now the next thing to do is to pop the prompt and get Claude to work on it. I was going to show you how that works next.
Sounds great. Just a very quick sort of question. So the skills you're mentioning, from what I understand, they're in different repository, but are they open source?
Yeah,
like can people, so we can use them basically.
Yeah,
right?
you can use them. Yeah, they're just
Awesome.
yeah, unfortunately I forgot that I would want to show them. So I didn't open I can open the tab after. I don't want to
no worries. Yeah, I'm pretty sure there was a QR code at one of your
Yeah,
slides,
that's right. Yeah, the QR code will take you to
and that's on the recording. So if you can share the slides, that's great, but we'll also have the recording for people so you can actually see it. Nothing will be lost basically.
Yeah.
Okay, Petar, I'll let you continue. Thank you very much.
Okay, so does everybody get that? Because now what I created was I created a backlog for Claude to work on. Okay, so now I'm going to go back to this window here. I'll say so this one here says take an issue and then create a branch for it and create a worktree for that issue. And in this case, we're popping an epic. So it creates like one branch and more work tree for the two issues that we created. Okay, so now it's doing that. And it takes maybe a bit of time to do it, maybe 30 seconds or so. Okay, yes, and don't ask again. Okay. So it's telling actually what it's doing. So it's created a pull request and all that. So like I'm going to look back on this thing here. This is now back in GitHub. The one thing you'll see is that it created a branch. Okay, so now it created a branch called GH97. That's the epic, right? So it created a branch for that. But also on the local disk on my computer. So this is the actual repository. If I look at the directory above, okay, so there it says he created this directory here. Okay, so that directory is actually what's called a work tree in Git, and it's not a copy of the whole repository, it's just like a link to the repository. Okay, so all the work by the agent now will take place in this directory here. Okay, in my main repository, which is what I'm showing you here, is going to be on the main branch. Okay, so like when the agent does its work, it's going to switch itself to this epic branch to do the work. So that way, if I start a second agent, it'll start a second work tree and they can work in parallel without conflicting with each other. Okay, so now I can say, okay, and see now the next thing is to say do work. So this one here takes about a minute. It's actually going to create the code that I was describing. So that's what it's doing right now. It's actually now writing the code. But to do that, what it does, it's going to download that issue from GitHub, and it's using the issue as the prompt to know what code to write. So you'll just follow what the issue tells it. Okay, so, and actually we kind of actually closed the loop at this point in time, right? So if I look back in the presentation, and actually see here, it kind of says, I'm going to create this function. I don't know if anybody knows Go, but even without knowing Go, you can see like print hello world. Okay, that's all it needs to do. That's what we asked it to do. So you figured out how to solve the problem you asked it to do. And now it's just creating the code. Now, if I look here, that's kind of that one. Now I actually already moved on to this memory management here, and I just showed you how that works. And then I talked about work trees, and just maybe to give a bit of a more background. So like in terms of um, how Git works on your local machine, they have this system where they don't make you copy the same repository twice. Instead, they link to the object into one repository from something that's called a work tree. Okay. And if you change something in the work tree, it leaves your main repository behind until you do the merge. Okay. So that's kind of a good thing because it isolates different pieces of work at the same time. Now, you don't need to know how work trees work to be able to use them because Claude knows. Okay, so you can just tell it create a work tree over there and it knows what to do. And it's kind of 3 commands to do it. So yeah, and I just ran this do work so that I just did that. Okay, so let's go back here and see what the agent is up to. Do you want to proceed? Let's see what it did. So it created this. And now it says, you kind of want to say yes to everything, otherwise you're just waiting around. Now, while I'm doing that, I'm going to show a separate window. So in this window here, what I did is I opened open code. So open code is a different agent, unrelated to Cloud Code. And in this case here, it's using GLM 5.2, not the model that Cloud Code is using. Cloud Code uses Anthropic models. So I can actually, what I can do here is I can show you the issues. And what I want to demonstrate here is that the two agents don't have to be from the same company. They can actually be from two separate companies. In fact, what I can do here now, I don't know what this thing here is doing. Let me see what it's cooking. So I could actually start in a different coding harness altogether. I could say I want you to pop this issue 99, and it would work in parallel to Cloud Code. I'm not going to do that because something might get broken. But yeah, you could do that. And then that way you can parallelize your work and do things in parallel. When you work with the desktop app from Claude, yeah, from Anthropic, that Claude desktop app has an ability for you to have all of these different threads at the same time. And in the background, they use something like this so that you can have these threads and they're not interfering with each other. All right, so that's kind of that. Now, the only thing I want to show you now is like that question, going back to the question we had earlier, why did you have to create an issue? You already had issues, okay? So some of the issues you can put in there are issues that are standing work items you want done. So in this branch here, for example, in this repository, oh, sorry, went the wrong way. In this repository, the issues I have is there's a dependency on a different repository. So I have like upgrade yourself to that repository. Okay, so in this one here, it says go to that repository, and then like there's a file that it needs to modify. And then when you modify the file, I want you to run the regression suite. That's basically what it does. So that's kind of that kind of issue. And this one here is something that's related to how the code gets generated. This one here automatically actually, what I just showed you, I'm doing here by hand. This one does all that automatically from beginning to the end, all by itself. So it generates the code and then deletes the code. And I can then test how well Cloud Code generates code. And then this one here is when I'm done with this demo, I'll run this issue and then I'll kill like whatever files I created here, I'll delete them all and be at a reset state so I can do the demo again the next day. Okay, so those are kind of the issues that I have that are standing issues. And let's see what this thing is doing. Say yes. So yeah, okay, so that's running. All right, so I think that's kind of all I had in this presentation. Okay, the only thing I wanted to say was that when you have these models, you can actually get the model to do a lot of work because they're capable. But I think it makes sense for you to stay in control and to decide what the tasks are you want done and which order and how you want to build the thing you're building. Okay, so and that's kind of like, well, everything I showed you here kind of leads towards that conclusion or request that you work this way, which is before you start doing the work, figure out what you want to build, what the components are, how they relate to each other, record that, and then figure out which order you want to build them in, and then you get Claude to just generate them like this. And what I found is that if you have a good description of the software you want to build and you pick the right kind of language, then you're probably good to go. Okay, so in this case, I'm using Go. Go is good because it's kind of like Python in a lot of ways, but it has a compiler and it has a typing system, so you can catch a lot of mistakes before you even try testing your code. I've tried this approach with Python, and Python, I would say, they generate code, but they have no way of verifying the code is correct. So you get a lot more errors if you try and do it in Python. I also tried it in C++, and it can go in C++ pretty far, but if you want to have templates, then no, it's not going to go anywhere with templates. So it depends on the language and also what the model was trained on. Yeah, and for this, actually, I have these blogs I've wrote, so they kind of break this down and explain every skill, and there's links to all the repositories and all the skills, and you can read those files if you wish to do that. And then the demo is over here. Now, I promised I would open that other repository with the skills. I can show you what skills look like. And actually, after this, I can go and add that to the presentation as well. So then you have it. Okay. So in my coding skills directory, what I have is I have the same set of skills for all the agents I use. Some of them, like Cursor, I use at work. Um, Claude, I use in my private life because it's actually really good. And then OpenCode, I use typically when I run out of credits on Claude Code. So like towards the end of the week, they won't let me have any more credits. And then I switch to OpenCode and I use it. Okay. But all of them work the same way. Now, if you look under Claude directory, they have this part called commands. And one of those issues is just a markdown file. So for example, I showed you guys this make work. And it just says this is how you do it. Okay. So you kind of issue this command, gs issue list, which is a CLI for GitHub, and it gets the list of issues in GitHub. And then it says read all these files. And then once it's done, it says now this is how you create a new issue. Use this command here to do that. And that's all it did. You follow that markdown file. The one that's pop is different because it'll go and get the issues. And then based on that, it'll check out a certain branch, it'll create a work tree with a new branch, and then it'll kind of start working on that issue in the new branch. Okay, so there's like a lot of Git specific commands here and GH specific commands. That's one is a bit more elaborate. Yeah. Now the thing about these is I don't write these by hand. Obviously, Claude Code writes them all, right? And then as I'm using Claude Code, I can see there's a mistake and I'll get it to correct the mistake. So yeah, you don't need to know how to write these skills or commands. Claude Code knows, and all of these, actually, I have this thing that says, I have like a cursor version of this, which is slightly different, but kind of the same at the same time. I could actually just go to Cursor and say import all the commands from Claude Code into here, and it'll just create this automatically. Okay, so I think you just have to be able to think about what you want and then being able to express it to the agent and it'll create it for you. Okay, so going back to here, it's just asking for permission. So this probably is not going to finish sometime soon. I think it's almost at the end, but not quite finished. All right, so that's kind of the last of my slides. I don't know if there's any questions at this point.
There is.
I have a question.
Yeah.
Nick. Yeah, Nick is here, Nick Mansurov. Can you so there is the waterfall phase, right? So you get to your product refinement requirement document. You break things down, right? And then you get the tasks, and then you get multiple agents to execute the tasks. So okay,
Yeah.
So that's what you must have demonstrated. Now,
Yeah.
what I want you to focus is the iteration piece. Whether this is, so there are probably two ways how that can be started, right? So when some of the tests fail, right? You can spot it, or maybe you have an agent who spots that if you have good tests to begin with. But things are that at some point you will find that because you don't have enough tests. That's part of the iteration, right?
Yeah.
So you have some tests, and at the end, so all your requirements are satisfied. But then you look at the result and says, I missed the requirement. I missed a test. So then you need to go back.
you have to
how does
learn.
that work? So when
Yeah.
you want to go back and let's say modify, add a requirement and add a
Mhm.
test, and then have the
Yeah.
whole thing repeat itself.
Yeah, so it works actually the same way. Okay, so but before we go there, I want to kind of point something out about tests. Okay, so when you build software in layers, right? So you might have a bottom layer, and that bottom layer really relies on unit tests. But by the time you add a second layer, that layer is already using all of the existing components. And if you do it right, all the components reinforce each other. Okay, so I don't need to test a lot in the second component, and the second component already tests the first component, right? Like even if because it's exercising what the first component that it depends on does. Okay, so like you're kind of building this sort of like house of cards that becomes a software in the end in different layers, and every layer depends on other layers. So like everything is kind of reinforcing each other. So you have to really be able to think like that in terms of software. Now, at any stage in time, you can use this make work command. Okay. Now, it depends on what you're trying to do. But like the reason why I mentioned this layering is because I don't typically check the test at the very bottom of it, right? Like I might be like, so I mentioned a project there. That project has in it something like 10, 20 services that all work together and do something together. Okay. So I'm actually at that point in time just kind of testing to see does the end-to-end thing work. Okay, and if it doesn't, then I have a bug or a missing functionality. That's kind of, I know, but I don't actually test like every function. It's impossible. There's 80,000 functions. There's 80,000 lines of code in that project, right? So yeah, you have to kind of set up your testing so that it tests things end to end, and then you're kind of seeing does everything work end to end. But if you find something doesn't work, and actually for testing, for that, I also use Cloud Code. So I'll say to Cloud Code, I want you to bring up this service, and I want you to try this out. Okay, and then he might use there's a software called Puppeteer. He might instruct the Puppeteer to do something, or he might actually create REST calls itself and just access the REST calls against the entire service. And then if something doesn't work, then you also tell Claude in that specific project I use OpenTelemetry, go through OpenTelemetry exchanges and see why this didn't work. Okay, and then he's going to have a hypothesis why it didn't work. Cloud Code has a hypothesis. It is not always correct. Okay, so I would say maybe it's only correct 1/3 of the time. Okay, that's kind of what empirical, my own personal experience with that. Then you say, okay, so I want you to fix that bug. And then it's going to use this command. It's going to create an issue here. Some issues are actually marked as bugs. Actually, I don't know if I have any in my closed issues. There could be some that are bugs. Um, Maybe not here, but yeah, sometimes it's a bug. Okay. And then it'll create an issue that's a bug. And then you just go through the same process again. You go and you say, I'm gonna, do the planning for the bug. I'm gonna break it down into issues. Maybe I need to change some documentation. Maybe the design was wrong, right? So I might change the documentation. That can also be a bug. And then when I do that, I generate the code, and then I go back to, I'm gonna run all the tests again and see did it work this time. Okay, so it's just sort of instead of you doing it, you have to think about Claude Code doing it, and then you kind of let it go do it. And you can, to some extent, you have to trust that it's doing the right things, but I find that it usually does. So, yeah, it kind of works out. Yeah, I don't know if I answered that question, Nick, or not.
Yeah, thanks. The pretty good. Thank you.
Okay.
Uh, Thank you, Peter. There are like tons of questions, and we have not much time left. So I'm going to read it through the chat because if you don't mind, because it's easier if I do it. So there is one follow-up question from Trevor. So when you're designing an app and just iterating on a design, uh, you aren't creating issues for all of that early creative work.
No.
So you're creating the issues only for the actual build. That's the question.
Actually, I can also do it. I also create the documentation using the same method. Like what I usually do is I'll have like a discussion with Claude or some other agent about what the design is. And then I'll say, okay, so now that we have the design, I want you to write the documentation for it. And then I'll go read the documentation to see if it captures what I wanted in my design. Now, the trick here, though, is, somebody mentioned the waterfall model. It's kind of like a mini waterfall model repeated many, many times, like the agile thing with the spiral. Like you want to be able to kind of go move it until your cognition allows you to move it. And it depends on the person, right? Like in this case here, like writing this documentation for Hello World was pretty easy, but like the declarative agent one. I mean, that took a lot of iterations and a lot of different back and forths and a lot of, oh, I made a mistake, I should go redo all this. So it wasn't like it all came out at the same time. I didn't conceive the whole application in one day. Like you start and you learn and then you kind of go back and you modify and you go on from there. Yeah. Another question?
Thank you. Okay, another question from Aaron Rice. I hope I pronounced that correctly. Thank you for the talk today, and by the way, great talk from me as well. Do you use any software patterns to standardize the development in PRDs?
In PRDs, yeah, actually in my head I do. So I showed you I was using Go. In Go, many of those patterns don't really work in Go. Go doesn't have a very rich set of interfaces. It has very simple interfaces and it doesn't have inheritance. So a lot of patterns that depend on them don't really work. You have to kind of really rethink it. But yeah, like when I do my SRD or PRD, I'll say, I want you to use a linked list. And I want the linked list to be working like this. I'll say like it's a queue and you use a linked list, or I'll say it's a table, but I want, like you kind of tell it exactly what you want it to implement, right? Now I don't use so design patterns kind of going to that book of 4 design patterns. Those I've done that in the past, but you know, those design patterns, maybe I should say this, and maybe this is a controversial statement. I think for me, they were a maintenance thing for people, right? And now we're using agents. You really have to question, do we still need to use design patterns, which are useful for people, right? And I'm not really sure. I don't know the answer to the question, but you kind of go like, okay, so really what I have to think about is the code I generate has to be easy for the agent to read and has to be maintainable for the agent to maintain, not for me, right? So if I was me and I like the factory design pattern, I always use it, but like for an agent, he doesn't care. So, like you kind of have to really kind of think your way through that too. I don't know if that answered that question or not, but it's sort of design choices that you have to say, but then I have to include this second aspect, this tool you're using to generate the code.
I would personally say like my perspective, design pattern is still important, but yeah, we can leave this
Yeah.
discussion to another day.
Yeah.
There are more questions. So, question from Rhythm. How did the agent come up with the acceptance criteria? Was it defined? Is it something in the skill or the prompt or your
Yeah.
original issue that, so how did it come up with the acceptance
So there
criteria?
should have been, if I remember correctly, that's a part of the requirements. So when I write the spec for this, it's in the requirements. It'll say what the acceptance criteria is. Okay, so here's summary. It says goals, and then I'll have the acceptance criteria.
Okay, and so this YAML is something that you're putting in on the design phase, right? So
That's right, yeah. So when you design the component, you're going to say
Yeah.
like it needs to be able to, these acceptance criteria, basically define the tests you need to test later.
Okay, and then the agent just refines per issue which of these goes where, essentially, right?
Yeah, exactly. So like, for example, like you see how I have like multiple requirements here?
Yeah.
So like if it's a very complicated, actually, one project I have is a generated like ls, the command. It has like 1,000 requirements, right? So like that one, it breaks down, like it'll do like the requirements in groups, right? And then for each requirement, there's an, see here, acceptance criteria says that's for these requirements. Right, so like as it knows that I'm going to implement these requirements, that it knows which acceptance criteria it needs to have to be able to finish that task. Yeah, this was like this. I created this with trial and error. Like it seems easy when I show you now, but like when you start and you kind of go like, what does he know? What does he not know? Like you have to kind of figure out, right? But like if you can actually give it some structure, and then that structure then enforces things later.
Sounds great. Thank you. Question from Poolkit. How do you save and sync the command? Actually, I had this question as well. How do you save and sync the commands across different agents? Do you copy, paste them in each agent's commands
No,
folder?
no. What I do is I kind of clone this repository, and then I create a soft link to .cursor in the other repository, right? So so this is my repository with the skill, and in this one on my personal computer, which I'm using right now, that's kind of like this. It's a soft link, and it should be in .git ignore. I added to git ignore because it's annoying. Like you add the link in the .git. That's why it's not checked in. It's not in the GitHub because I don't want it checked in. It's just a soft link. You can do with, I don't know if you know ln-s. That's what a soft link is. Yeah.
Sounds great. I have a little follow-up in a little
Yeah.
different direction to this question. So when you have multiple agents, when they're claiming issues, when they're claiming, how does agent B know that agent A already claimed certain issue? Like
They
how
don't.
they
No.
don't?
Yeah. So typically, like so there's a project called Gas Towns where somebody tried to automate that piece. Um, and and maybe you can then have some kind of coordination between the agents so they don't all go pick the same set of issues at the same time. But for me, I'm the one who knows that this guy here picked up this one. I'm gonna wait for it to finish, and then the next one can go pick up the next one. I'm the coordinator, and like I think that's completely reasonable. If I can write 5,000 lines of code a day, and I don't know if you subscribe to that kind of metric or not, but like that's a lot more than I used to write before. And I'm like, there really need to be 15. Like, I think 5,000 is fine. So, like even if I'm the bottleneck, at least I understand what's going on. Like I know what work is being done, who's doing what, and then I can plan, right? But like otherwise, if you let him go crazy, I don't know where you end up in the end. Like a lot of chaos.
Sounds
So
great. Thank
yeah.
you. There is one very specific question from
Okay.
Ivandro, which I don't know if you know. I mean, I certainly wouldn't. So thanks for the session. In my company, we have UX design in Figma. How can I
Yeah.
use this process while respecting all the Figma settings?
Yeah, I think I don't use Figma, so I don't know. But if they have a CLI for Figma, or an API to Figma to be able to get what you want, then I think that takes you there. Yeah. If they don't, then you can't, right? Because actually, like in our company, they use Atlassian Confluence, right? And so, like, and actually, that's maybe a problem, see, because what you want to, and I don't know, I mean, obviously, if your company has procedures and whatever else, you can't really change that. But like for these agents, the requirements have to be next to the code, right? If they're not, the agent, when it's generating the code, can't read the requirements. So like you kind of have to change your processes to be able to enable that. So like if somebody told me like, yeah, must use Figma, here it is, I was like, I'm gonna scrape that thing and get all the requirements in here so it can generate it by itself. Because otherwise, the whole automation breaks down right there. There's like a bottleneck that a person has to fill in, right? So yeah. I don't know if that answered the question or not, but like, yeah, it's kind of like that.
I think it does. And Ahmed posted that Figma probably has MCP, so that
Oh yeah, the MCP server. Yeah, that's another way to go. Yeah, but
yeah.
I don't think you want to go through an MCP server. You want to be able to capture that because, yeah, I mean, you're going to make a lot of calls with an MCP server, and every time you make that call, that's spending tokens. Like it's like this hidden overhead that you're adding to yourself. And if you have like, I don't know if you people on the call have a limit to how many cursor dollars they can spend every month or whatever, like you want to save that money and go further than without. So yeah, find cheaper ways of doing is what I'm saying. Um,
Hey,
Um,
Petar, have you looked at the economics of this? So how does the equation changes if, let's say, I have a local deployment for a model?
yeah, so yeah, I use many. So the reason why I use Alama is because it's a lot cheaper. But if I'm gonna say a local deployment, like I have a Mac M4 with 128 gigs of RAM, and that Mac cannot run a model that can do what I just showed you.
Oh, okay.
Yeah, I mean those 32 gig models are not gonna work. Like you need a model that's a lot bigger. Actually, I think you need probably like 792 gigs is probably the minimum you would need to get a reasonable. This GLM 5.2, and that's almost 800 gigabytes of that. And if depending on your commercial situation where you work, maybe they don't want to have a commercial agreement with Olama. But Olama just charges you for GPU time. They don't charge you by the token. So I think that's actually quite good because that makes sense to me. So, Yeah, but when you use Cloud Code, if you use it in personal life, I think my subscription is like $300 a month or something. And I'm pretty sure I use well over $5,000 a month. So I think they're almost paying me to use it. Like, right? But yeah, like at work, it's different. At work, they pay for every token. Then you see your bill every month. You kind of go like, oh, maybe that's too high. I'm not sure, But yeah, yeah. That's all I have to say about that. You have to look for better solutions that are cheaper. Yeah.
Yeah, thank you.
Okay. Thank you very much, Petar. Thank you very much, everyone. Great talk, and I think it was great conversation. We're at top of the hour, so I believe like in Meetup chat or everywhere, like Petar, if you can take more questions, etc., then probably
Okay.
yeah. I mean, it would be great if people can still find you. So I'll
Well,
put
you can just I saw somebody already connected with me on LinkedIn. That's probably the best way, And
yeah, great.
yeah,
Connect
yeah,
with
yeah.
Petar on LinkedIn, and if you have follow-up questions, ask him there. So I'll try to put this recording of the talk on YouTube probably tomorrow, and there'll be a link at the meetup page, etc. So again, thank you very much for joining, and we'll should have a speaker for September sometime soon. So just follow the announcements on the meetup page, and hopefully you will have great talk in September as well. Petar, thank you very much. It was a pleasure.
Okay, thank you for having me. Bye.
Thank you. Bye, everyone.